Okay, we're going to do some select problems in the review book. I will write them all down and send them out to you as we go. There'll be a couple additional ones for you to work on tomorrow, and I'll have office hours. Let's take a look at some more limit problems. Here we have this one right here. X approaches 0, sine of x over x. If I stick in 0, sine of is 0. So I know I'll be L'Hopital right away. So now here is why I'm showing this one right now. When you take the derivative of the top, it's cosine of 5x times 5. You have to take the derivative of the inside over 1. Now fill in 0, and I get 5 cosine of 0. Cosine of 0 is 1, so the answer is 5. People forget about taking that extra 5 there, and they leave it, and they get the answer to be 1 instead of 5. So there's A11. I'm going to pause for a second. Okay, let's take a look at A15. On 0, and once again I'm going to get 0 over 0. So I will L'Hopital the problem. So I'll get on the top, I get cosine of x over 2x plus 3. I'll now fill in the 0. The cosine of 0 is 1 over 3. So the answer is 1/3. So L'Hopital will work for you on every problem except two types. One are the exponentials we talked about the other day, and the other are absolute values. Okay, because absolute value signs don't have derivatives at certain values. And the way we approach this problem is the following. Okay, well, think of, if you see an absolute value sign, you have to think of two separate pieces right there. You have to think of what happens if x is a positive number. And think what happens if x is a negative number. So you can work them in, oops, I can't see them. If you work both problems and get the same answer, you have a limit. So I'm going to put in 0, I'm going to L'Hopital it, and I'm going to get 0, I'm going to get 0, 0, so that's a L'Hopital, the answers. So on this side, I get the limit as x approaches 0 of 1 over 1 is 1. On this side, I get the limit as x approaches 0, negative 1 over 1 equals negative 1. See how it doesn't head to the same spot? These are only true for absolute value ones. That means that the limit for this one is non-existent. I generally don't think we're going to see a problem like that, but if you happen to see absolute value signs at the point where the cusp is, you're not going to have a limit. It's not going to approach the same pieces. Okay, we're going to look at problems B5 through B9, which are ones we went over the other day. We can see I have a function here that is a piecewise function. It's made up of parts, but it's also discontinuous at different spots. Here's what I already know. It is going to be discontinuous here, not continuous. It is going to be not continuous here. And at this point, it's also not continuous. And it is also not, well, if it's not continuous, it's not differentiable, but it's not differentiable as well. It's not a cusp because there's a hole in the graph. So let's see what type of questions they're asking me about on this one right here. And I'll keep flipping back and forth so you can see. This is page 111, by the way. B5, the limit is x approaches 2. The limit is x approaches 2 of f of x. So if I look back at the problem, the limit is x approaches 2. Does it head towards the same value right here? As x approaches 2 from both sides, the height of the graph approaches 0. So the answer for B5 is equals 0. It's hard for me to move around the pages. Sorry about that. The function is defined between negative 1 and negative 3. They want me to know where it has values between negative 1 and negative 3. I'm going to flip back. I'm not going to turn the page back to it. You guys can turn back. Between negative 1 and 3, the graph has values at everywhere but 2 locations. Now, Lucas said, what? 2 locations? I lied to you, Lucas. I am going to look at the graph. But Lucas said there's 3 breaks in the graph. It just wants to know where it has values. It doesn't have a... I lied. It does have a value. It has a value at 0, right there. It has a value there. So it's only... is it undefined here? Nope, it has a value there. So it is defined for every value of the graph because it has a dot for every value of the graph. So for B6, the answer is D. It does have a value at each spot. It only, if it had a hole with no dot in it, it wouldn't be there. The function has a removable discontinuity. That's wherever the hole in the graph was. For b, that's at 2. X equals 2 is b7. Yep. On which of the following intervals is f continuous? So I have to see where it is. There are no breaks in the graph, including the endpoints. So I'm going to write them down so I can see them here. It's -1 to 0, 0 to 1, 1 to 2, and 2 to 3. And the only one that doesn't include the endpoints is the 0 to 1. Okay, so let's flip over and take a look. I have it written down so I don't have to flip back. Here it is. Let me get my red pen. So between -1 and 0, it is not continuous because there's no point right there. In between 0 and 1, in that interval there, it is continuous. Between 1 and 2, no, it's continuous because it has a hole right there. Between 2 and 3, it's not continuous because there's no value right there. Please remember that everything but the second choice included the endpoints. That's why at B8, we're choosing that one right there. And our last one we're going to do here is the function has a jump discontinuity when it goes from one spot to the other. If you take a look at the graph, I'm just going to double check, at 1 it takes a big jump. So that would be the jump it's going to take right there. Okay, so we finished A11, A15, and B5 through B9. Now the problems you are going to work on tomorrow, and I will be available for in-class help, is if you have the new review book, it's just going to be about derivatives. We're going to turn to page, there we go, page 141, and you are going to do problems. It's going to seem like a lot of them, but it's just basic derivatives. We're going to go A1, so page 141, A1 through, let's go through A14. And these are non-calculator. You're just going to try the non-calculator right now. We will do calculator problems on a different day, but you're also going to do B1 through B8. And you see those are table problems like we talked about. I think that's more likely it's going to be there. Really quickly, I'll help you out with one or two, because the answer, you may get a right answer, but you may not see it there right away. Let's take a look at A2. A2 is you want the derivative, so it is a quotient rule. So it's U prime V minus U V prime over 3x plus 1 over V squared. Now if you look, I know I've got the bottom right because it's all connected right there. And the reason I'll be seeing that answer, first of all, you got this right now, I'm happy. That's the part we're going to have to work on, we're going to work on, because we're not going to have multiple choice problems. If I had to figure out the correct answer from this batch, I would distribute things across the top, so I'd get negative 3x minus 1 minus 2 plus x. Oops, I forgot to multiply the 3 in, didn't I? 3 times 6, negative 6. Positive 3x. The x's cancel on out, and I would end up with negative 7 on the top. So I believe the correct choice would be A. Double check. A2 is A, so I do a couple extra steps to find the problem. There's nothing in here outside of our derivative rules that we're working on. They may look a little different. There may be some radical signs on there you have to change to 1/2 powers. But if you have any questions, I'm going to send them out right now. I will be available for your office hours tomorrow to go over anything. Okay? Take care.